As an engineer, we were tasked to design a function generator to generate a sine wave, a triangular wave, a rectangular wave, and a sawtooth wave. We've done so at this project, and we've inputted a system where we can vary the amplitude and the frequency. It also shows real-time graphs of the changes and the signal. So under the project conditions, we were to design the code and a GUI that can work with the code. And so we've done that, and that's what we'll show. Okay, so this is the UI we're presented with. And what we have is the waveform type range from 0 to 3. So it starts off with sine waves. So in order to see that, we need to introduce an amplitude and a frequency, which can be changed with these sliders or can be typed in directly. And we have it set up so that you can see the time scaling change and the amplitude scaling change real time. So if I increase this, you'll see it scales real time and tracks it. We have it going for 2 cycles, which is nice because it gives a clear view of the function. And we can go ahead and we can change the waveform type to 1, which is a square wave. And you can see that here, changing. And 2, this is the sawtooth wave. Again, changes with the sliders. And finally, we have the triangular wave, which again, you can change in real time and have it rescaled as you move the slider. So that's the UI. Now, going into the we can see here that we have the functions, the code introduced here that allow the functions to be used in the sliders in the UI, but our project partner Guillermo will go a little bit more into detail with that. In terms of the main code, we've set up, we have our function introduced. We called it fungen, which is a fun generator or a function generator. And we have here, we put in our constants and our basic formulas, which is the period, the step, the number of steps, step size, the Fourier coefficients, which is FC. We thought 1,000 was a generous number, give you a really accurate function. And we have SZ is the step size, and we have that maximum at size T, and for the Y zeros we have it ranging from 1 to the size that would be inputted there. Okay, so now moving down, this is the code where we have it switching. We use the switch function to switch between case 0, 1, 2, and 3. This goes from the sine wave to the square wave to the sawtooth wave, and this also goes to the triangular wave using these. So if you put in 1, it defaults to sine, 0, it defaults to sine, 1, rectangular, and etc. So you can see that here. And if you wanted to explain a bit, Andre, a bit of the math behind that, some of the theory.
Okay, the theory part for this project will mainly use the Fourier series as a reference. The Fourier series is a mathematical model that allows any periodic signal to be modeled in terms of sine and cosine waves. In Fourier series, the coefficients are weighted differently and allows each term to act significantly on the sum of terms. So in this project, we have square wave, we have sawtooth wave, we have triangle wave, and sine wave. We can see that the square wave, triangle wave, and sawtooth wave is combined by the infinity amount of sine wave with an extremely small amplitude and different frequencies. And for application of the Fourier series, actually, especially for electrical engineering, we have used the Fourier series in many regions, such as imaging processing, vibration analysis, and signal processing.
Hi, my name is Guillermo, and today I'm going to show you a little tutorial about the function generator app. It's going to be a quick tutorial to go over the code and the main functions of the application. To start off, we have our main components. We have a knob for the frequency, amplitude. We have a display for the waveform. These entries are basically displaying the frequency and amplitude at whatever frequency you have. You have also the input interface, the digital input interface that the user can type their waveform. These are representing the analog inputs. So if we go to the code here, onto code view, there are basically four functions. One is the main function, which is the most important one, is the function generator app function I created. Here's where you display and create the waveforms. So you have the time, the period for each waveform. This is only applies to the size applies only to number of steps to the sine wave, to the square wave, triangular wave, and sawtooth wave. T, which is basically the period. As you can see, you will see a little bit later on. The graph updates itself, like the time frame, which is very nice. And this is the sample. So the more samples you have, the better and more accurate waveform you have. You also have your different statements. So if you the default case is 0, so the sine wave. You have amplitude, which is the main amplitude, and you have your frequency. In case number 1, you have your square wave. This is the very important part here. So, and can only be odd values. So if you add a different, according to the formula, mathematical expression, if you add different values like an even number, you won't get the sine wave, the square wave. So n can only be between odd numbers, and this is the derived coefficient for it. This is just a for loop that loops every sample every time, and the same can be said for the square wave, for the sawtooth wave. The only difference is sawtooth are the coefficients, and also n can now be any number. For sawtooth, there's no, can be even or odd. For triangular wave, can only be odd number, n can only be odd, which is very important to know. Now at the end, we found the coefficient, and we plot the graph using a for loop, and we plot them using these plot function. So if we go here, real quick, we're going to run the application. So here we can move the amplitude, but since the frequency is 0, now you can see a better view. The maximum stated amplitude on the assignment, on the project, said that you wanted to go to up to 100 volts. So we have the amplitude maximum and the frequency up to 100 hertz, and the period is displayed on the left, on the x-axis. So if you change the amplitude, change the frequency, and now if you want to change the sine wave I was explaining before is the default waveform. If you change the to 1, you can change the square wave. Now the frequency, if you go to 0, there won't be anything. If you go back, then you have your triangular wave, and finally that's the sawtooth wave. That's now the triangular wave as specified on the project. So here it is, and thank you.